Welcome to the second tutorial about ProSum. My name is Alberto Marin, and in this video we will talk about advanced modeling strategies. We can consider this model with the first plan of the structure already modeled, and we will import a DXF file with the plan of the first level of the structure. Okay. As you can see, the first level of the structure is different from the base level because there are openings in different position or openings that there aren't in the basement floor. To model this floor, we will use the same command we have used for the basement. The first thing we have to do is to set the reference with the command in the ProSum menu, set panel reference, and we have to choose the material and the thickness of the masonry. Then we can create the element with the command create wall. So as we did in the first video, we have to click at the beginning of the wall, at the end of the wall. I remember you that if there is a intersection with an orthogonal wall, we have to take that point as the end of the wall, and then we have to click at the beginning of the window and at the end of the window. As we did in the first video, we have to set the height of the element below the window and the element above the window. We can also suppose that the roof has two different angles. So the height of the wall at the center of the wall we are modeling is different from the height at the beginning of the wall. To model this situation, we just have to change the height of the wall. ProSum generator automatically considers this situation, extending the height of the masonry walls. Okay, in this case we are lucky because we have an intersection with an orthogonal wall just in the middle of the wall, where we have the longest height. But if we don't have an intersection between an orthogonal wall or other structural elements, we anyway have to divide the modeling into parts. The first part and the second part that we will do in this way. Then we can continue to model the other walls. We can also consider windows in different position. So it's not a problem for ProSum generator. The program will automatically adapt the geometry of masonry beams and walls of the equivalent frame. Once we have completed the introduction of the data of the wall, we can check the structure to find out some problems in our modeling. So this is the first problem that the program automatically finds out. We have element with the intermediate nodes, maybe additional inspection are required. We answer yes, and this is the problem. Due to different position of the openings in the two different levels of the structure, we have a column that is not connected to the element of the basement floor. To connect, to make this connection, we have just to use this command, intersect. In this case, we have a problem. The program can't automatically do this intersection. The problem is the typology of the element of the equivalent frame. In fact, this is a not rigid element that has not stiffness. So we can't divide this kind of element. So in this case, to connect properly the element, the column of the first level to the beam of the basement, we have to change the type of element. So instead of non-rigid, we can consider a rigid element, and considering a rigid element, we can use the command intersect and divide without problems our beam. The second problem the programs find out is to align the offset. Also, offset cannot be connected each other. So we have to change the typology of element also in this case. But the program can do this for us automatically. We have just to click yes when the program asks us if we want to correct the geometry. Then we can do another check to control structural elements, and the program doesn't find out other problems. So we have solved all the intersection between elements. But in this point, we have another issue that requires our attention. At the first level, we have a wall that we don't have in the basement. So this could lead to problems during the analysis because this element could have a tension, stress. So to avoid this tension, we can model a beam below this element to connect the node at the base of this wall with the other nodes of the frame. So I remove the XF file and I isolate this plane of the structure. To model this beam, we can use the same properties of the rigid offsets. So this material and this cross section. So we can use a setD2Reference command to choose the section and the material. This material is a rigid material with a very high stiffness. To create the beam, our rigid link, we can use this command to create a polygonal starting from this node and considering all the nodes at the base of the wall. Before going on with the load assignment, we can check the structure, and here we have another problem. So element with intermediate nodes, we have to connect the link we have just modeled with the orthogonal wall, and we can make this operation automatically with intersect. In the last part of this tutorial, we can discuss about correcting mistakes. The general rule is that we can't manually change the element of the equivalent frame. If we want to do some changes in one or in some of the wall of our structures, we have to use these two commands, change wall and redo all wall. To use change wall, we have first of all to select the element we want to change, to modify. As an instance, this element. Then with change wall, we can modify the geometry, the position, and the position of the openings of our element. If we want to change some of the properties that are in the reference of the panel, like material or thickness, we have to use this command, redo all walls. This command have effect only on visible elements. So if we don't want to regenerate, to change properties to all the structure, we have just to consider the element we want to change, as an instance this side of the structure. We can select and isolate this part of the structure. We can set different reference, so changing as an instance the material, and then using redo all walls to assign properties to the element. This video covered the principal issues we can have while modeling a masonry structure with the equivalent frame approach. In the next one, we will discuss about how to assign loads to the structure and how to run the analysis and to control the results of linear and non-linear analysis. If you need more information about ProSum, please contact us at assistenza@2si.it for technical support, or amministrazione@2si.it for commercial information.